Hello, my name is Issac Newton, and I'm here to tell you about my 3 laws of motion. But first, let me tell you a little bit about myself. I was born in 1642 in Lincolnshire, England. My childhood was not at all joyful. My father died when I was quite young. Then my mother remarried and left me alone to live with my grandparents.
It's okay. It's okay.
But then my uncle encouraged me to attend Trinity College at Cambridge University. I graduated in 1665 after earning my bachelor's degree. But the same year, Trinity closed due to bubonic plague, so I returned to Lincolnshire and spent those next 2 years in solitary academic pursuit. At the same time, I made advancements in calculus, optics, physics, and astronomy as well. Some of my major inspirations were 2 gentlemen, or shall I say boys, named Galileo and Aristotle. Then, soon after, Cambridge reopened. I took position in Trinity and further advanced in optics and creating a reflecting telescope. I longed for recognition, yet dreaded criticism. Robert Hooke challenged my ideas and caused me to never publicly show my work again. So, I returned to Lincolnshire, where my attention shifted to motion and forces, and from there came a universal law of gravitation. One afternoon, I was sitting under a nice, fresh, glorious, regal apple tree. When suddenly an apple fell from above. It was amazing! Because of the glorious apple, I ended up creating my 3 laws of force and my universal law of gravitation! Woo! Yeah! Woo! Oh my gosh! Yeah! Now, before I get into my 3 laws, let me educate you a bit on what advanced words I may be using during this explanation. Now first is a push or a pull. Get it? Inertia is resistance to change, but we will get more into that a little later. Mass is the stuff things are made of. Or if you want to be all scientific, mass is technically a large body of matter with no defined shape. Mass is not ever affected by gravity. Many people confuse weight and mass, but the difference is weight is affected by gravity, which mass is not. The amount of mass remains the same no matter where you are. Weight is the force that is applied to that object due to gravity. The weight equals force times gravity. Yes, very big. And then weight is small, up. Acceleration of gravity is basically the rate of change in speed that acts on an object that is moving only by the force of gravity. Regularly, the acceleration of gravity is symbolized with the letter g. The g equals somewhere around 9.8 meters per second squared. Universal law of gravitation. There is a constant gravitational force between each and every 2 objects in the entire universe. This force is called gravity, and gravity attracts things to each other. With gravity, the larger the mass, the stronger the force. Gravity attracts the 2 centers of objects, and everywhere you look around, you can find exhibits of gravitation. Now, motion is simply a movement or change in position or place. Any movement or change. I'm telling you, any. Now that we're done with my vocabulary, let's get on to my 3 laws of motion.
Newton's first law of motion, otherwise known as the law of inertia, states that an object in motion stays in motion and an object at rest stays at rest, unless acted upon by unbalanced forces. Haley, get up!
I don't want to get up.
Why not?
I have a severe case of inertia. Just deal with it.
For example, when a ball is dropped, free fall occurs. The ball continues to fall until it is stopped. In this case, the ground stops the ball. If the ground was not there, it would just keep falling. This is because an object in motion stays in motion unless acted upon by unbalanced forces.
The ball is at rest. This is because the ball hit the floor and the floor stopped it from moving, and it will stay at rest unless this happens. Isaac Newton's second law simply states that force equals mass times acceleration. So, when someone with a certain amount of mass jumps on a trampoline, they end up reaching a certain height. But if you add more mass to the original mass, then he or she ends up reaching a higher height. This is because with more mass, the acceleration is greater, and with more acceleration, the force is greater as well. And that force pushes or pulls the object with more mass farther than the object with less mass.
Oh, wait! I forgot one definition. Free fall. Now, free fall occurs when weight is the only force acting on the object, like when the apple fell from above me. That apple, my friends, was free falling. I'm a smart guy, crazy about science,
Loves optics and mathematics too.
I'm a smart man, crazy about physics.
Loves forces and astronomy too.
One day an apple fell on my head.
And he thought
Wait, why did that happen?
Galileo was a huge inspiration.
To me, I remembered what the apple was doing. I'm free,
Da da da,
free falling.
free falling now I'm free falling now
Yeah,
I'm
I'm free.
free falling now I'm free falling.
It was free falling.
Woo!
Ba ba ba. The third law of motion states that every action has an equal and opposite reaction.
one example is a rocket launch. When a rocket launches,
When flames push out to provide the force, the rocket launches. The reason this works is that when the flames push against the ground pushes back, causing the rocket to actually launch.
Here is another example. Let's see what happens when I push Sage. When I push Sage, she pushes back. You see? Action reaction, people. I can't help it.
I can't breathe in this thing. Oh. Oh. Okay, I know. Was that in the frame? I don't know. Oh. Julia. No! I almost caught that! Oh! No, wait, throw it back. Okay, ready? Just keep going. No. These are working. So cool. Can we please? Oh my goodness. Oh. Julia!
She dropped her binky. Julia, okay?
Yucky. Can you shut the door? This is embarrassing. Nope.
One sec. Again. See if I can. Oh my god. My goodness. Oh my god. Pumpkin. Oh, that hurt my knee. We're all gonna come together. Oh no, that's right. Okay, ready? Okay. Hey Matthew, do you have a pony? Julia, I'll do it with you.
I'm a detective.
For example. Julia, chill. You gotta take a chill pill. Okay. Wait, Haley. Okay. It's going. You got a beard on the back of your head. Just keep going, Julia. Just keep going. S. Oh. Julia.
Don't put any of this in, Haley. Jump. 3, 4.
E. T. U.
Dogs. How do I put this on?
Look at the
Oh, spell return.
Oh my god, are you serious? Haley.
Stop it. How do I stop it? Stopping.
Oh my god.
Oh, Santa Claus is coming to town. Yes, it does. Haley, I have to write. He studies the human body.
I.
Go faster.
N.
¿Cómo estás?
Is it going?
Yeah. This hairdo isn't working out for me.
Why not?
I have.
Let's go.